Alright, so welcome back. We're going to look at the cotangent graph now, and you'll notice that the first thing I'm going to do when I graph my cotangent graph is make the same setup that I made with tangent. So if you remember from the tangent video, we start at negative pi over 2 and then go up by multiples of pi over 4 until pi over 2. That'll get us a good glance at the one period of cotangent. That's unlike sine, cosine, secant, and cosecant, where we were going 0, pi over 2, pi, 3 pi over 2, etc. Okay, so there's a couple ways you could actually fill this out at this point. If you know the tangent one, and you know cotangent is the reciprocal of tangent, you can just take the reciprocal of all these values. That's one way to do it. I'm going to pretend for the moment that we don't know that, we don't have that other table filled out, and let's just remind ourselves that tangent of an angle in the unit circle is y over x. So that means that cotangent, since it's the reciprocal, will be x over y. And so if we rotate negative pi over 2, then x over y is negative 1, is 0 over negative 1. So that's, filling it out in the wrong place. Negative pi over 2 is 0 over negative 1, but that's just 0. And if we go to 0, right, x over y is 1 over 0, which is undefined. And at pi over 2, tangent is x over y, which is 0 over 1, which is 0. And if I go to, if I rotate pi over 2, or pi over 4 rather, if I rotate pi over 4, that brings me here. And again, whether you view it as just understanding that this height is the same as this length, so my x and y coordinates are the same, so x over y would be 1. Whether you view it that way or you have to go out and actually do the cotangent of pi over 4, it would be 1 over 1. Either way, it doesn't matter. Either way you do it is fine as long as you get the answer. So if we rotate negative pi over 4, we'd be going down. And whether you can understand, whether you understand that the x and y coordinate at that point is going to be the same. So, except one of them is going to be negative. The y one's going to be negative. Whether you understand that, or you have to go out and actually just do it out, it's okay. But in any event, the cotangent would be 1 over negative 1, which is negative 1. Alright, so what does this look like? Well, notice in the tangent graph where there were asymptotes, now those are zeros for cotangent because they're reciprocals. So that makes sense. So at pi over 2 and negative pi over 2 we have zeros. And at 0, where tangent was 0, we actually have an asymptote. Mr. Bowen just walked in. I'm going to have to do the rest of this video now with him distracting me. Very difficult. Might want to say hi, Mr. Bowen? He doesn't want to say hi. Fine. That's fine. Never mind. Alright, so now I'm going to graph negative pi over 4, negative 1, and pi over 4, 1. And so at this point, we need to get a sense of the shape of cotangent. We just kind of have a few points. So let's take a look at this Geo Sketchpad animation. So I'm going to show cotangent, and you're going to notice that it has, the curves kind of behave similarly to the tangent graph. So notice they're not straight lines, right? Oops, I'm graphing both of them. That's confusing. Now I'm hiding the tangent one. Let's reset that. This is all because Mr. Bowen walked in. I'm going to animate the points. There we go. So now look at the cotangent graph. So on each section in between the asymptotes, right, the curves are decreasing. Okay, the graph is decreasing, but it still has that, sort of curved shape that the tangent graph has. Okay, so make sure you don't make them so straight and rigid when you graph them. Okay, so that means we're going to have to sketch this going down and this one going up. And so we have one full period here of cotangent. But what we need to do, if you want to get a sense of the full shape, or you just want to get a different section of the period, what we should do is we can follow the pattern at this point. So after a 0, right, coming from the left, we have a -1. So that means right here, I'm going to plot a -1 y value. And then after that, we have an asymptote. So there is one section of cotangent where we're sketching in between the asymptotes. And so now the asymptotes are obviously evenly spaced. There's one at pi, there's going to be one at 2 pi. There's going to be one at -pi. And Mr. Bowen just cracked his neck. So that was distracting. I apologize if you heard that. Okay, so after you get one period, you can appeal to your pattern recognition skills, and you can get more periods that way. But in any event, here we have, looks like 4 full periods of cotangent. So let's note what the period is. Just find a point and then find another corresponding point and figure out the distance between them. So I like to use those zeros there. So there's a 0 at -pi/2 and 1 at pi/2, and so that distance is, well, it's going to be pi, right? So the period of cotangent is pi, like tangent. Period is pi. Notice that's different than sine, cosine, secant, and cosecant. Okay, now let's describe the domain. So we're going to describe the domain in the same way we described it earlier. We're going to say it's -infinity to infinity except where the asymptotes are. And so there's an asymptote at 0, so x cannot equal 0. And then the next one's at pi, the next one's at 2 pi, so they're going up by multiples of pi. So that's the best way to describe them. The range, as with tangent, is -infinity to infinity. And the x-intercepts we'll describe as, there's one at, well, let's see, there's one at pi/2, and the distance between the zeros, well, from pi/2 to 3 pi/2 is a distance of pi. So they're going up by multiples of pi. Asymptotes will just copy what we wrote down in the domain, except we won't put the line through the equal sign. The asymptotes are at x equals 0 plus pi n, where n is an integer. And there are no extrema. Okay, so there's hopefully a painless way of graphing tangent and cotangent. You do want to compare their shapes, right? They're very similar, but they're also very different, right? They're in different locations. One of them's cotangent decreases on each of the sections in between the asymptotes, whereas tangent increases. Those are just things you might want to take a look at and notice. They may help you when you have to graph them yourself.